Right. So as I'm waking up in Minnesota, there's yet another day of snow, slush, and rainfall happening. So I'm excited to be inside doing this conference today. How's the weather where you're at, Adrian?
It's fine. I see. Somebody just. Could you fix the spelling of Cockcroft on my speaker pop-up?
Oh,
It should have a C between the K and the R. I have too many C's in my name. Apologies for that. Yeah, I'm in California between rainstorms. We're on top of a hill, so we don't have flooding, but there's rivers near us that are still flooding. So some of our roads are out.
right on. So your shirt is pretty great. So
Yeah, I
great.
got this at QCon,
Yeah.
and I thought I was looking through my T-shirt drawer, going, I need some chaos-related one. I'll get this. So that would be a good one for this event.
Cool. And we got some people from Haiti joining us. So hello.
Oh,
So
cool.
awesome.
Got some good Haitian rum in my bar.
Yeah. Cool. We just got your name updated too, so that works out
Thank
great.
you. That's good.
So
It's a
cool.
common problem because some people do spell it that way as well. But anyway,
Yeah. I know with my last name with Schillerstrom, people always have it interesting. So that's where my nickname Shilly kind of came from. So it's
yeah,
kind of great.
that's why I'm Adrian CO on Twitter and things, because so you don't have to try and spell the rest of it. You can get the CO part. That's fine.
Yeah. Awesome. Well, cool. Everybody's joining in. Time zones all over the world are kind of interesting. So we had people pulling all-nighters yesterday, but I'm going to just start and we'll let people come in. So welcome everybody to Chaos Carnival 2023, sponsored by Harness, day 2. We have Adrian here, but before we get started, just wanted to say thank you for everyone who participated yesterday and attended the keynotes that Adrian Hornsby and Uma Makaro gave, and our engaging workshops that Harness and Blameless gave. And special thanks to our social media fans. And for anybody new coming that wasn't able to attend yesterday, we have video recordings. We'll have video recordings of today. But I just want you to sit back, relax, enjoy, engage, ask questions. Yesterday, people won prizes. So our Kahoot drawings or our Kahoot games during the day, we have a couple of them. We're giving out prizes to the top 3 people that win. And then for all of our Twitter competitions, so if you send a picture of your workspace, your environment, something fun, and tag our handle, we'll draw a raffle at the end of the day for 3 $100 Amazon gift cards. So thank you for that. And if you can go into the booths and visit today, watch one of the demos that's recorded. We're going to do another raffle and give away some gift cards for people that are engaging in the booths, as well as the new AirPods too that we're going to have a raffle for at the end of the day. So looking forward to doing that. And there's just a keynote change quick. So Anna Medino couldn't speak today, so Uma Makaro and Karthik are doing an Ask Me Anything event later in the day, which is great. So I'm looking forward to that, as well as the Chaos panel discussion. But without further ado, I'm really excited to introduce Adrian Cockcroft here. The last time I talked to him, he was in Hawaii, and I was, so excited to see him. And now he's in California, and I'm just jealous of the weather that he has there. But I've been a fan of him since the early days. When I started my chaos engineering career in 2016, I was always looking at his videos, presentations, and reading. So I'm just honored to have him here with Chaos Carnival. Thankful for him. And hold on a sec, my phone is ringing. Oh, I just got paged, so I'm going to turn it over to Adrian. I have to go respond to an incident, and hopefully he can teach us how to never have incidents again. So feel free to share your screen and take over. Thanks, Adrian.
Okay, well, thank you. And we'll just, let's see, share screen, get the right window up. Yeah, so this is what I wanted to talk about. Why isn't everyone doing chaos engineering? Try and give some thoughts on how to convince your boss, get started easily, become continuous resilient. Just a little bit on my situation. I was working for Amazon until about the middle of last year. I'm now an independent sort of tech advisor. I'm advising Nubank as sort of a large customer. I'm also advising Harness, and have got a bit more involved there, and Catchpoint and a few other small companies, Amped as a little startup. So that's kind of what I'm up to right now, and I'm also spending time doing things more about sort of green software and things in that area. So I've got a few different things I'm doing. Also, I think 2 years ago I spoke at Chaos Carnival, which I think was the first one. So, and I used a presentation deck which looks similar to this one. So I kind of went, well, what changed, and updated a bit from that. But I tried not to just repeat myself, and I'm assuming that some people saw it and some people have seen my talks. So there's more. This is kind of a refresher, but I've got some new content in here too. And when I'm done, we're going to have a little a demo showing how to be continuously resilient. So this is my definition of chaos engineering. You're going to have failures. You want to mitigate them. You want to limit the impact of those failures by mitigating them. So you have to run experiments to ensure that the impact of failures is mitigated. It's kind of just a little rewrite of the long wordy version that that I said to see around. So, the first blog post we did about Chaos Monkey in 2010. It's now 13 years on. I'd like to do like a Google Trends to see what's going on here. So, we sort of bumbled along for a bit, but somewhere around the time that 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 Max started paying attention, it started getting busy. So there we go. Maybe it's all his fault. Um, And so where is this coming from? So the sort of ancient history here is effectively disaster recovery, data center failover. People are still doing it, but they've been doing this since the 70s. And that was kind of the state of the art until cloud came along, and cloud really let us build chaos engineering because it gave us API-driven infrastructure and much more ephemeral infrastructure, so we could replace things without having to go and talk to a vendor and spend weeks and days to weeks messing with it. So I think cloud let us build chaos engineering, and that was the sort of the change. And now what I think we're at is continuous resilience, where it's just part of your daily processes. And that's kind of this push from like, okay, I've tinkered with chaos engineering a bit, to this should be the way everything happens. That's the transition that I think we're kind of getting to the end of. So we build redundancy into systems. So if something fails, you've got an alternative to fail over to, right? That's pretty standard. But your ability to fail over is sufficiently complex and hard to test. So quite often when you try to use that redundancy and you try to fail over, the whole system falls over. And this comes down to, this is a basic principle of reliable systems. This is an old principle, goes back for decades. Any mechanism for switching between alternatives needs to be order of magnitude more reliable than the things it's switching between. Because if you look at the reliability of a system, it's the reliability of the two things in parallel. You say, well, now that's better. But if the switch is less reliable than the thing you're switching between, the reliability of the switch dominates. And this is a really big problem for the kinds of reliable systems we build, because we quite often don't test those switches. So the switch is the least tested part of your system. If that's true, it's probably the least reliable part of your system. You better have just not switching at all. Just have one thing. Don't try and build redundancy into a system unless you're absolutely sure that the switch you're using is so simple, reliable, and well tested that you can guarantee that the switching process you have is really going to work. So that's just something to think about whenever you're trying to build a reliable system. So how can we do better at this? So one thing to think about is the reliability is like fraying a rope. The thing about ropes, they have lots of strands, and eventually there aren't enough strands left and it snaps. So the thing that, the force that snaps the last strand in a rope is not causing the failure. The fact that you let it get frayed beyond its design point, you're eroding the safety in the system. And this kind of, you see these kinds of things all the time. There's safety that's built into a system and they gradually get eroded. We saw this in the banking system recently with SVB, right? The safeties were being eroded by lobbyists, and eventually, enough things ganged up on SVB that they've gone out of business. And I've had to spend some time fussing with that because I had an account there. So what you want to know is how much do you have left in your system and how afraid it is. This is an old slide I've been using for many years. It's because I think security has a similar set of concepts to chaos engineering. They're trying to find the weak spots in the system. But I like to break this into layers. You've got your redundant infrastructure. You've got a layer that you're using to switch between alternatives. You've got an application that's trying to run on top of that. And then there's people. And the people layer is where a lot of the failures happen and a lot of the opportunity. It's the best opportunity to do better starts at the people level. Then you sort of work your way down through the infrastructure. So even if you've got no chaos engineering tooling or processes, just getting the people coordinated is going to make a big difference. Another great quote, Chris Pinkham was the first engineering manager for EC2. And he said this once at a conference, I wrote it down. You can't legislate against failure. You should focus on fast detection and response. So fast detection is observability, the ability to see quickly what is going on. Like if all of your metrics are delayed by 10 minutes, you're going to have trouble figuring out what's happening. And then can you respond quickly? Do you have control over the system? So if we look at sort of control theory and what's been going on in highly reliable systems for decades, there's this book. I've been promoting this book for a long time, Engineering a Safer World. I think Nancy's working on a new edition of this book right now. I don't think it's quite out yet. So look for that coming up. Lots of great stuff here. The main thing is they run an annual conference that's free and it's online and it's coming up, I think, in May. It's coming up fairly soon. So if you go to the MIT website, you should be able to find it. If you're really into this stuff, definitely a great place to go and spend some time really immersing yourself in really properly engineered reliability. So if it is a control theory problem, what we mean by an outage is that the application is out of control. And the word out of control is a very defined meaning, right? If it's in control, it's self-regulating, it's all behaving the way you want it to. Out of control means it's doing something that it shouldn't be able to do. And this could because automation's failed, there's some network partition, you've got a database crash or corruption or anything else. But what you typically do when something is sufficiently broken that it's out of control in our world is you try to fail over to an alternative copy of it. So that's the failover that I'm talking about. And in order to do that, you've got to deal with floods of alerts, and you've got to be able to reduce those to actionable insights rather than just having every dashboard read and every log browser just scrolling up the screen faster than you can read. And your observability system not only needs to stay up when everything's down, so you probably want it on some different infrastructure, but it also needs to cope with floods of alerts without failing. And then to really do that, to show that that's the way you're set up, you need to run these regular chaos engineering experiments. And one of the things that's maybe not so obvious is that retry storms are a big problem. When stuff starts failing, you get lots of retries, and if you've got work amplification and a retry storm, the system gets stuck in that state. It becomes catatonic. This is quite often why the only thing you can do to something is reboot it. It's just gummed up. It's because internally what it's got is a retry storm. The way you prevent that is and make systems so that they not only don't get into a bad state, but they recover from it quickly and automatically, is to reduce the number of retries really to zero except at subsystem entry and exit points. What I mean by this is if you're calling an AWS API, sure, retry that. But if you're calling from one microservice to another in your system, there should be no retries. Work your way back up to the entry to make sure that the thing that originally asked for that work to be done is still waiting for it. That's the key thing. It's when work's going on and the people that made the initial request have long gone, right? So you want to reduce timeouts, that drops off in requests. And the other thing, if you're looking at on the cloud with multiple availability zones or multiple data centers, you want to route calls within the same data center, within the same zone. As soon as you start routing calls across zones, you're basically creating a problem that's going to take you out. It's going to make it much harder to survive the outage of an availability zone. So in order to manage this and keep it simple, keep it something you can understand, what you really want is to add symmetries, constants. So you want to have a high level of automation so things are always done the same way every time. You want consistent configuration as code. You don't want to have lots of different configurations. You want to use the same instance types. You want services, versions, zones, and regions to be configured in very similar ways. Now, quite often somebody will come along and say, well, it'd be more efficient if we optimized this thing in this place. It would use less resources, but you have to kind of counter that and say, okay, but are you really saving much, or are you just creating a problem that when that thing goes down and everyone looks at it, they can't figure out what state it's in anymore because it's set up differently to some other region? So you're always trading off a little bit of efficiency against this consistency. And this kind of comes down to sort of cattle versus pets, right? If you have individual machines that have names that you get unhappy when they're unhappy, those are pets. If you have a fleet of machines that are replaceable, automated, they have numbers instead of names, those are cattle. You want to have herds of things. So what I like to see is if it can be the same, make it look and act identically. If something is different, make that clearly visible. And test those assumptions continuously. And then I like to focus a lot on getting people to understand zone failover before attempting multi-region. If you're going straight into multi-region, you're just never going to get that to work unless you have, if you can demonstrate that you can survive losing a zone repeatedly, then you're ready to start thinking about, okay, how do we extend that to multi-region? All right. So as I mentioned, as data centers move to cloud, these fragile manual disaster recovery processes have got standardized and automated. So why doesn't everyone run chaos tests? I think some of it is you can't get there from here. Your current environment is so flaky that if you run a test in it, everything collapses and everyone starts shouting at you. Or the product managers say, no, you're not doing that on my app. Or maybe everyone wants to do it, but there's no funding. You haven't managed to hire anyone who's a specialist in it. It's just scary. I had one CIO say, we don't want any chaos testing in production. We don't want chaos in production. No chaos. So I said, what if we call it continuous resilience? Is that, oh yes, I definitely want continuous resilience in production. So maybe you just need to change the name. We said, well, we're going to do the same thing, but we're going to call it continuous resilience in production, and we're going to call it chaos engineering in test. Does that make you happy? And they said, yeah, that makes it happy. So it's like, how do you explain to the non-technical people what you're doing, and they don't like the idea that there's chaos around? So I really like to use the words continuous resilience rather than chaos engineering nowadays. And you're just too busy because you're dealing with so much firefighting because the system keeps crashing. But what's the real reason why everyone isn't running chaos tests? It's because you haven't had a big outage yet or recently. I mean, like, if you ever have a big outage, that's when you go, okay, now we're really going to fix this and we're going to make sure it doesn't happen again. That's when you get the chance to go in and set everything up. And I'm not sure if people remember, but back in 2008, Netflix had a multi-day outage. We corrupted all our databases. We were hard down, had nothing running. This was DVD shipping days, but we had nothing running. Actually, I guess we had the beginnings of some streaming, but we were down for 3 days. And as coming out of that was when we went, yeah, we need to do something differently. And that's when we really started thinking about chaos testing and cloud and the whole of the other different things that we did. But that big outage caused management to go, okay, we're doing something wrong. We need to do something differently. So it is all hard sometimes to convince management. So one thing you can do is to go to management and say, okay, we're going to put you all on call, right? You're all going to be carrying a pager for us so that when the site goes down, we can call you so you can talk to the press and tell customers what's going on and all that stuff. And then actually call them reasonably, when you do get these failures. And maybe after a while they go like, can we call, can you call me less often? Can we make this site a bit more reliable? Put the pain where it needs to be. At Netflix, we did this with developers. We put all the developers on call, all the ones who were customer facing, and they built really reliable code and really reliable systems once we were on call. And I think that developers don't like being on call, but I think it's good for them to at least be on call some of the time, so that they understand where the pain is going to the right place where it can actually be fixed. And really, what you're asking management to do is notification, corporate PR triage. One of the things, when I was at Amazon, I was a VP at Amazon, and all the VPs at Amazon are engaged in basically an on-call system. And if the site goes down for some reason, if Amazon goes down, everyone gets notified saying there's an outage, it's a big deal, be careful what's going on, be careful with what you say in public. So it turns out I was actually on stage at I think a Gartner summit or something like that, when in 2017, early in 2017, when S3 failed. Like, I was down for some reason. I forget when it was the last time that S3 had a failure. And I was on stage chatting about stuff and all these things, and the PR person sort of appeared at the end of my talk and said, "Oh, we have to leave quickly." So okay, I went out, and I got into a, like an Uber or something like that. No, it was Lyft. It was a Lyft, and Lyft was still working. Lyft runs on AWS, and it was still working. And when I was in the States, said, "Yeah, there's an outage, and we just need to get you out of there." So. Um, So before anyone noticed. But anyway, it's interesting actually that Lyft stayed up. And another thing you can do to convince management is report the cost of failures and the cost of firefighting. And they look at that and go like, why are we spending so much time and money on unplanned work? We shouldn't be doing this. And say, okay, well, we need to make the system more robust so that we can reduce that cost. And I have an analogy here. Most of you growing up may have been told, don't run with scissors, right? You have scissors around the house and they're sharp and you shouldn't run around with them. And basically, any time you're holding something sharp or something fragile, you move around slowly and carefully. But if you've got something wrapped up in a box or in its packaging and it's not sharp, you can run around, you can go super fast, you can throw it to somebody, it's all fine, right? So there's something about having a safe system that lets you be faster. And really, if you think of that at the system level, if your system's more robust, you could innovate more quickly because you don't have to spend so much time testing, coordinating, and firefighting, because you're making tiny changes that you're putting into your system that are safe things to do, right? And you can back off a lot on the testing that's needed to do that. That's what customers want. It's what management wants. They want to go faster. So how do we make changes safe? Many tiny changes, highly automated, put them in the CI/CD pipeline. Do I think there's test-driven development and behavior-driven development are things that developers know about. What I want is chaos test-driven development. Let's put this in the CI/CD pipeline for every developer. And then we're basically taking continuous delivery and we're turning that into something that gives us continuous resilience as well. So the principle here is there really is no economy of scale in software delivery. If you bundle together more and more change into a release, it's less likely to succeed, right? Not just linearly less likely, but worse than that, right? If you put two changes together, it's more than twice as likely to fail because you've got the bugs that are in either side plus interaction bugs. So what you want to do is keep trying to make the smallest possible thing the thing that you're delivering, and that requires a very efficient and automated CI/CD pipeline. So you make your change, you check it in, and it just flows through. And this is really where you want to test how your system is going to mitigate failures. So how would you get started? Let's just go back to, where do we start? First of all, who would you get on a call? Make a list of those people. Set up a regular meeting. I like to say something like every second Wednesday feels about right. It's often enough that people pay attention to it, but not like it's taking up too much time. The first thing is get everyone on the same page. What's your call protocol? What channels do you use on Slack? What phone numbers do you use? Just make sure that everybody knows what's going on, so that if a call comes in, oh, this is a failure. Everyone knows how to operate and how to work together on it. And then who has the passwords? Who has the keys? Where are the dashboards? All the things that you might need if there's a failure. And then out of every meeting, every 2 weeks, you say, okay, what incrementally can we get done before the next meeting? And a few people take a few actions to do small amounts of incremental improvements. So every time you meet, you've got a little bit better. You've got the situation's improved slightly, and you're making progress towards being able to handle a failure more quickly and efficiently, right? Which is fast detection and fast response, what we want. And then make a wiki list of things that might go wrong and what you might want to do about it. It doesn't need to be finished. It just needs to be everything anyone's thought of. And you start trying to prioritize and think about, well, what would you do if, say, the DNS crapped out, and who are the vendors and who are the experts in DNS, and what would you do if you had to switch DNS provider or something like that. Make sure that wiki is somewhere that doesn't go down with the rest of your infrastructure as well, because that's also kind of an annoying thing that happens. And you just gradually build up to saying, well, okay, we think we've got a response to a failure. So we're now going to suggest some experiments to test those responses in staging. And then eventually we're going to get to building chaos tests into development and deploying processes into production. So really, what I think we've got here is that testing this mitigation has really moved from this scary annual experience to where we should be today is automated continuous resilience. And I think we've got reasonably on time here. I'm going to actually have a demo now of some new capabilities in Harness showing how you can build this into your environment. So let's get out of this and stop sharing. And that's going to run a video for us to show us how you could actually do this in practice. And we'll have a bit of Q&A.
Hello, everyone. In this demonstration, we will show how you can execute chaos experiments as part of the application deployment pipelines. The application under test today is Online Boutique. It is a demo microservices application that we have deployed on GKE. It has several microservices. The one that you're seeing here is the front end of the website, which talks to the carts microservice, the shipping payment microservice, etc. It's a combination of stateless and stateful microservices. As part of this demonstration, we are going to deploy one of the microservices that belongs to this application, the carts microservice. And we're going to execute a chaos experiment immediately post the deployment to verify the resilience of the new version of the carts microservice that we have just deployed. Running chaos experiments as part of application deployment pipelines enables you to achieve continuous resilience. Let me describe the pipeline here. We have a pipeline that says boutique cart service deploy with network chaos. Let us take a look at a previous execution of this pipeline. So the image that was deployed as part of this pipeline happened to be resilient. You can see that the rollout step is followed by a chaos experiment execution step. As part of the pipeline, we can define an expected resilience score and compare against it. We get the actual resilience score to be greater than the expected score in this case, which is why the pipeline completed successfully. In the cases where the actual resilience score obtained is less than the expected resilience, we are going to effect a rollback of the microservice. We go back to the previous image associated with this deployment. With that explanation, let me show to you how you can add a chaos experiment as part of a pipeline. Users can add any number of chaos experiment steps as part of their deployment pipelines. You can add a chaos step here. Provide an appropriate name. Select the desired chaos experiment from the chaos module. Add it to the pipeline. Set an expected resilience score against the experiment. Define a failure strategy for experiment failure. Typically, you would roll back upon chaos experiment failures. That's all. So now we have a chaos experiment added to the deploy pipeline. This was done for illustration purposes. Let's discard these changes and proceed with the execution of this pipeline. The experiment that we're going to do as part of this pipeline is a network connectivity loss experiment. So We talked about the online boutique application being composed of several microservices. Cards happens to be one of the important microservices, one which the website interacts with. So when we are going to cause network disruption to the dependent service, in this case, the cards, we would still want to see the application handle that gracefully and not cause degraded user experience. As far as the SRE is concerned, the expectation is that transient network issues to dependent services does not take down the application and does not cause user impact. It is handled within the application, and it is to be expected that the services are configured in highly available manner, by which network transactions can continue to happen via other channels, other paths to the microservice replicas, and user experience continues to be normal. We will test this assumption in two ways. We are going to look for automated checks, validation constraints around application behavior. We are going to look at the basic resource health check. We are going to look at the cards availability check. So this is the availability of the specific microservice under test. And its availability is necessary for the other downstream applications to interact with it. We're also going to look at the impact on the user in terms of performance and accessibility. We're going to look at what is the latency on the front end or the website, which is the user-facing component. And our expectation is we're going to look at a minimum of 250, a minimum value of 500 microseconds, which is a high value, but this is just for illustration purposes. We're going to look for a minimum latency to be maintained by the front end, which ensures the user operations can still continue. While these are the automated checks, or in other words, hypothesis validation constraints that we are going to perform as part of the experiment run, we are also going to be looking at application behavior on a Grafana dashboard. So the microservices belonging to online boutique are being tracked here, they're being monitored here. The queries per second and average latency metrics are being tracked for the individual microservices. As far as this particular experiment run goes, we're going to be specifically looking at the cards and the front-end microservice. We're also looking at the overall application availability statistic here. And we expect it to be 100% available all the time. So we have some automated checks that are being performed using the resilience probes, and then we have some manual checks that are being performed by looking into the Grafana dashboard. With that said, let us go ahead and make the change that triggers the pipeline. So the cards microservice deployment spec is being maintained in a Git repository here, as you can see. You can see the card service YAML. We are going to change the image. We have the good image that has been deployed. The pipeline was a success last time. Now we are going to go ahead and deploy an image which is going to introduce some anomalies into the application deployment, into the cards microservice. And this is going to adversely impact our availability and performance constraints. When we are going to go ahead and commit this change in the image, that is going to trigger the pipeline. So let's refresh the pipelines page and check whether the pipeline has been triggered. You can see that the deployment pipeline has been triggered. Let's track its execution. We are doing the rollout of the new image on the application. So once the rollout of the cards microservice is completed, it is going to trigger the chaos experiment to cause the network connectivity loss. Let us take another quick look at what this experiment entails and what are the tunables provided to this chaos experiment. You can look at the default configuration. We have said that the application under test or the microservice under test happens to be the card service as identified by the label. It is of kind deployment and it is residing within the boutique namespace. Most importantly, you're going to be doing the chaos for a period of 60 seconds. Let me open up the experiment definition here. We can show that as part of the edit tunables section. Just as how you saw this on the dashboard, you can also see it as part of the default configuration wizard. You can see the app namespace is boutique, the app kind is deployment, the app label is card service. You can see that we're doing 100% loss. It's more like a black hole attack where we're ensuring that we're picking a random pod, cards microservice pod, and we are disrupting connectivity to it. And the chaos is going to be executed for a period of 60 seconds. And we have the probes configured here. Now, with that said, let's take a look at what's happening to this experiment. You can see that this is running as a result of the experiment being triggered in the pipeline. You can also check the view detailed execution. You can actually see that this is in progress. You can check the logs. You need to wait for a few seconds for the logs to be available, for the pods to be created, and the logs to be available. You can see the logs already got populated. Now let's take a look at what's happening to this website when we do the connectivity loss test. It seems to be good. We've gone ahead and refreshed this boutique page, and this was successfully refreshed. The experiment at this point is getting started. You can see that it's getting started. Typically, the experiment performs pre-chaos checks to see if the application microservices are healthy. And once the pre-check is satisfied, it goes ahead and injects the fault. And once the fault injection starts, we will be able to see the impact that is caused on the application. Let us also take a look at what's happening to the application when it comes to the dashboard. You can see the availability is dropping, and the latency of the front end as well as the cards microservice is increasing. So this is a bad outcome. This is something that an SRE would not want to see. So when we go ahead and refresh the online boutique website, you can see that this is still trying to load. It is not coming up. So the dependency is lost. The dependent service is not accessible anymore. The cards is not accessible anymore, which is causing a very high access duration for the front end. Eventually, this will time out at some point. As you can see, there is a 500 internal server error due to the application not being accessible. Under ideal circumstances, we would expect the deployment to be resilient and for the application to continue to be available and for the latency to be within permissible limits. But that is exceeded now. And that's going to cause the probes to fail within the chaos experiment. Now, just as we had some pre-chaos checks, the experiment is also going to perform some post-chaos checks. So once the 60-second duration of chaos has elapsed, the services are going to be restored to normal state. And then we're going to perform some basic checks against application health. And then the experiment is going to conclude. We can take a look at that in a few seconds. We would be able to see the application is returned back to good state. The latency is coming back to normal state. It is coming down, as you can see. The availability metric is increasing. And when it comes to the pipeline, you can actually look that the pipeline is causing a revert operation. So the chaos experiment, the chaos step is going to be failed as a result of the probe failures. You can actually see that the availability check has failed, the performance check failed. The health status has passed. This is because we are looking at the pod status before and after the fault injection. That was restored to good state. The application pods were not stuck in pending state, or they were not crashing. They did come back to good state after the fault was removed, which is why this experiment, this particular probe has passed, but our availability and performance constraints, which we were trying to verify continuously, are failed, causing an experiment failure. You can actually see this experiment has failed, and that is triggering a rollback at this point. The expected score was 90%. The actual obtained score was 33%. That's going to cause a rollback. And as part of this rollback, we are going to go to the previous version of the deployment, and we are going to ensure that the last known good image is applied. This way, we can prevent anomalies and application resilience issues to propagate into your environment. We can control it and ensure that you achieve or you maintain continuous resilience on your deployment environment. Once the rollback completes, you will be able to see that the system comes back to good state. In fact, once we stop the fault, execution system is already getting back to its original characteristics, and the application continues to stay alive. So with this, the rollback operation is completed and the pipeline has completed. You can see there's a resilience tab here. This resilience tab gives you a quick view of the probes that were carried out as part of this pipeline during experiment execution, which of them succeeded, which of them have failed. And you can view this in the chaos module, which will take you back to this chaos experiments detailed view. Of course, the logs can continue to be visualized. You can verify the log runs. You can see the Prometheus probe has failed here. You can also see a summarization of the experiment results here. And you can also obtain a report of this chaos experiment once it has been completed. So this is a quick overview of how you can execute chaos experiments as part of the pipeline. You can now see that the latest pipeline run that we ran was failed and caused a rollback. Thank you.
All right. Thanks for that demo, Karthik and Adrian. Appreciate that.
It's good. It's for me, it's good to see. This is something I've been talking about for a while, and it was good to see actual product support for the ability to make this continuous. So I'm very happy to see it coming together in this way. So it's not something that you do when everyone gradually gets around to it, like the sort of annual disaster recovery scenario kind of testing that people desperately try and avoid. It's just part of the way everything happens. I think that's the important move here.
Yeah, 100%. It's definitely making it more accessible. So we have time for a few questions. There's 3 in the poll. I'm just going to hit show on stage. We can just run through that. I'm going to actually invite John to the stage if you want to come engage for a minute. But if you are busy, that's fine. But yeah, how has chaos engineering changed from yesteryears to now? And what would you predict the trend is for the future? I know we've talked about it, but how would you
Yeah, I think that was kind of what I was trying to cover in the talk to some extent. I think it is just it's gone from being something that people do on an occasional basis if you're lucky to something that can be baked in. It's just, and I'm looking forward to more and more automation and tooling support, really. That's the trend that we're on. People need more reliable systems. There's more and more safety critical systems that have software in. More and more of what we do is becoming systemically important to the economy and to safety. So we've got to build systems that are reliable, and the only way you can prove it is through resiliency, continuous resiliency and chaos testing. I think it just becomes more important.
Yeah. This is a similar question.
Yeah, I answered that in the thing. So I just think there's more automation needed, particularly around zone and region testing. I think that's and we've now got the pipeline done. There's people doing zone failure testing, but it's still the automation and it isn't really baked into things like Kubernetes. If you sprinkle your nodes all across a bunch of zones, you don't really have a lot of the interprocessor into microservice calling systems, the way you call between things. A lot of the time it isn't scoped to the zone. And I think there's some hardening needed there that's going to make that easier to do. And then we need automation, particularly in the cloud providers. We need some really deep underlying APIs that can say, okay, I want to isolate a zone, I want to simulate that. We're starting to see a little bit of that. I think the AWS has some capabilities like that, but it's still simulate. Once you get zone level, getting to cross region, I think it's something a lot of people need to do. It's just still being very bespoke, and it's not a standard pattern that's well automated and well understood. So I think that there's a way to get there.
Yeah, let's run this one. I'll invite this person to stage if they want. Kind of following up from the last question too, is just around frequency. Like how often should you do those AZ tests? And in this question, if you have many experiments, do you run them all in the pipeline at the same time or a subset? How would you talk through that?
I would probably, I'd run a pipeline in a staging environment with a test load on it rather than in production, and I'd run all the tests that I've got. And that's, if it takes too long, then maybe you sort of concentrate on a few or you rotate them. But ideally you want to be able to have tests be pretty efficient and quick. So taking a minute to do something isn't too bad if you're looking at an automated deployment pipeline. Right? It's quite reasonable to have a bunch of canary testing and things going on. So what you're really doing is before you get to the canary testing in production, you're introducing some failures during the canary testing to make sure that the system is behaving in the right way.
Yeah, I definitely agree. especially if a test takes too long and we're impatient for the deployment, utilizing canary deployments or other best practices can help with that. And then you can just basically have protection around your pipeline for different, failure modes in testing. So back to the thought of being continuous and automated. So cool.
Yeah.
Let's see, we got a couple more questions.
Yeah. A couple more minutes. Okay.
Similar. Is chaos testing in prod, or is there dedicated? And
this is one way, and I probably should do another slide on this. One of the ways to get into chaos testing is to set up a dedicated set, like say, of cloud accounts that have chaos turned on, and then invite applications to deploy there. So if you need to be resilient, then we're going to create an environment which has got high resiliency turned on from scratch. In order to get from test to production in that environment, you have to go through, run through the jungle full of monkeys, or whatever the analogy you want. You might call it the jungle, right? You've got to get through the jungle and you've got to get to production. And that way, the only things that you have in that production environment are things where you can run chaos testing on them in production because you've gone through a test environment. And then if you can get a few of your most critical services into that environment, then next time there's a big outage, they're the things that stay up, and management will say, well, why isn't everything in there? And then put the pressure on everybody to put the things that are critical into that environment. So instead of taking your current deployment environment and trying to make it more resilient, you're creating a fresh environment which is designed from scratch with all the testing, whatever testing tools you've want, the harness pipeline, maybe you've got Gremlin or the AWS testing tools. There's a bunch of tools you can get, and just have those all running there before you put any code in there. And that way you got there first. I think that's that's my idea about having dedicated chaos infra. The cost of not doing this is you're going to be down more often. So that's kind of the cost side of it. Is usually, it's not, I mean, you want to have an environment that's there. I don't think it's a significant extra cost to have it. And then you gradually want to have more resilient things in that environment and just call back and forth from your other environments. I think we've got one more question.
So there's one for, how do you see security chaos engineering as a way to improve cybersecurity resilience?
They're linked. So there's a bunch of ways you break into systems by causing outages or DOS attacks, or causing things to fail in a way which fails open to security attacks. So I think that the team, if you've got a red team or whatever doing security testing, they should be well coordinated with the availability testing, because a failure of the security system causes outages, and you can cause security to fail by causing other things to fail. So they're very linked, and I think they should be kind of joined as the hip. They're very different people, probably in different teams, different mentalities, but there should be a lot of coordination and sharing of the kind of testing that's going on, and connecting the tooling on both sides. That's it. I think we're done. I actually have to dash off and do something else, but I'll be looking into the rest of the event later on. And it was great to see Adrian Hornsby yesterday doing his keynote. So thanks for the opportunity.
Yeah, thanks for coming. Appreciate it. Love seeing the continuous resilience talk. So take care, and we'll talk with you later on the show too. All right.
Thank you.
All right, bye-bye. There's 2 sessions for people to join next, so I'll hit end, and please join.